Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss congruency. Now, you might have heard this term before. Now, exactly what does this term congruency mean? Here we can see a 5 rupee coin and one other coin. If you put this 5 rupee coin on this coin, both of them will be of exactly same size and you won't be able to see the remaining part of this particular coin. Or we can say, since both the coins are same or identical in all respects, that is shape and size, if you put this coin on this, you won't be able to see this coin. Okay, so this is the concept of congruency. Similarly, here we can see all the four set of nuts and bolts are similar to each other. These triangles are similar to each other. If you put this triangle on this triangle, you won't be able to see the remaining part of the triangle. That means both the triangles are same or identical in all respect, that is shape and size. In our day-to-day life, we use many things which are identical in shape and size. Suppose I'm using maybe two Parle-G biscuit. Both of them, if two Parle-G biscuit I'm taking, both of them will be quite similar to each other. If I put one biscuit on the other, then the other biscuit we will not be able to see. 1 rupee note, 5 rupee note, 100 rupee note, or we can say different coins, maybe 5 rupee, 10 rupee, 2 rupee coins. Okay, so the two coin of the same denomination will always be same. If you put one coin on the other, you won't be able to see the other coin. We can also take the examples of two stems. If they are of same shape and size and we place one on the top of the other, then we won't be able to see the other. In each case, you will see that the two objects coincide with each other exactly. Okay, so this is the basic concept of congruency. So basically, an item is congruent to other when both of them are identical in all respects, that is shape and size. In this session, we are going to explore some different type of congruency. We will be discussing congruency through superposition, congruency of simple geometrical shapes, and we will also discuss some criteria for congruency of triangles. Okay, so let's begin the session. Now, first of all, let's understand congruency through superposition. I'm having two coins over here, and if I place this coin on the top of this coin, I can see that the two coins match each other exactly in the shape and size. Or suppose I'm having these many stems, I put one of the stem on the top of the other, I can see that the two stems are coincide with each other exactly. That means these two coins and all of these two coins are congruent to each other and all of these stems are congruent to each other. That means we can say the method of examining congruency by placing one object on the other is congruency through superposition. Okay. Now let's discuss congruency of simple geometrical shapes. Friends, the word congruent means equal in all respect. A geometrical figure is said to be congruent to another geometrical figure when both the figures are identical in shape and size. Okay, in other case or in other word, we can say that if we keep one figure on the top of the other, then they should coincide with each other exactly. Then we call them congruent. Suppose I put this rectangle on the top of this rectangle. Now we cannot see the green rectangle over here. That means this rectangle and the previous one, both of them are same or identical in shape and size. So we call them congruent shapes. Similarly, we can see two stars over here. Suppose I put this star on this star, then I won't be able to see this blue star. Okay. Now you can see you're not able to see the blue star. This star is exactly coincide with the blue star. Okay. So these two stars were congruent. Similarly, these two line segments, they are identical to each other, so we can call them congruent line segments. These two arrows, even these are identical in shape and size. These two figures, so all of them are good examples of congruency. Okay. Precisely, we just have to keep this thing in mind. If two shapes are identical in all respect, that is shape and size, then these two figures or images or diagrams or maybe shapes can be called as congruent. Okay. Now let's discuss congruency of angles. In these examples, we can see that the angle ABC, angle XYZ and angle PQR, all the three are same in measure. So we can say these three angles are congruent to each other. Okay, but we can see this angle, that is LMN, is not same in measure as angle XYZ or PQR or ABC. That means angle LMN is not congruent to any one of them. So in the case of congruency of angles, if the measure of two angles is same, then we call them congruent angle. We do not go on the length of the rays. As we can see over here, the length of AB is different from the length QR, and the length of AB is also different from the length YZ. So in the case of congruency of angles, we just see the measure of angle, not the length of the rays who are forming the or which are forming the angles. Okay. How do we write congruency? Here, triangle ABC is congruent to, angle ABC is congruent to angle XYZ. So this is a sign of congruence. Okay. We can also say angle XYZ is not congruent to angle LMN. Okay. Now let's discuss congruence of triangles. Friends, we have just seen that a geometrical figure is congruent to another geometrical figure if one of them can be exactly superposed on the other. Okay, now here we see different type of triangles. Here these two triangles and these three triangles. These triangles will be congruent to each other if they fulfill certain conditions. Okay, because in every case we cannot superpose one triangle on the other. Okay, since they are just figures over here, we cannot superpose this triangle on this unless until we cut the triangles on a paper and the shape we put, one shape we put on the other. Okay, so there should be various other methods to prove the congruency of two triangles. Okay, so let's discuss one by one. Now, suppose I'm having these two triangles over here. Maybe this is triangle A, B, C, and this is triangle P, Q, R. Now, for these two triangles to exactly coincide with each other, all their parts must be respectively congruent. That means line segment AB, AC and BC should be congruent to line segment PQ, PR and QR respectively. Okay, that I just write it over here. Suppose here I'm having line segments AB, AC and BC, and here it's PQ, PR and QR. Okay, so if the three line segments of this triangle are identical to the 3 line segments of this triangle, then these 2 triangles will be congruent to each other. Okay. Apart from that, it is also necessary that the 3 angles of this triangle should be congruent to 3 angles of this triangle. That means angle A, angle B, and angle C should be congruent to angle P, angle Q, and angle R. That means it will take 6 elements of the first triangle which are congruent to the 6 elements of the other triangle. Okay. So to prove that these 2 triangles are congruent to each other, we need to establish this 6 conditions. Okay. And we can also find out that if by cutting the papers on this shapes. Okay. Then after cutting, if we put the one shape on the other, and we can see that this triangle PQR can be superposed on the triangle ABC. Okay. So these 2 triangles are congruent. Now we have just discussed that a triangle is said to be congruent to another triangle if and only if all the 6 elements, that is 3 sides and the 3 angles of one triangle, are equal to the same 6 elements of the other. But before identifying these 6 elements, we should be knowing the order of the vertices of the 2 triangles in which they are matching with each other. Okay. Now just see over here. Here angle A matches with angle X, angle B matches with angle Y, angle C matches with angle Z. Along with that, AB is matching with XY line segment, AC line segment is matching with XZ, and BC is matching with YZ. So these 2 triangles are congruent. So symbolically we can present them as A is matching with X, B is matching with Y, and C is matching with Z. Okay. One more thing we can observe over here, that is A is matching with X, but A is not matching with either Y or Z. Similarly, B is matching with Y, but B is not matching with X or Z. Okay. So the order in which the angles match is important to identify the 6 elements that go on to make the triangles congruent. Okay. So we just can write all the 6 elements over here once again. It's line segment AB should be equal to line segment XY. Line segment BC should be equal to line segment YZ, and line segment AC should be equal to line segment XZ. And angle A is equal to angle X, angle B is equal to angle Y, and angle C is equal to angle Z. Okay. Now, an expanded study of the conditions of congruence will definitely help us to understand that the 2 triangles can also be congruent if instead of these 6 pairs, particular 3 pairs can be proved congruent. Okay. Now let's discuss them in detail. Now first of all, let's discuss SSS congruence. That means 3 sides of both the triangles are equal. We see a triangle over here. Suppose it is X, Y, Z, and it is P, Q, R. Now 2 triangles are congruent if the 3 sides of one triangle are equal to the 3 sides of the other triangle. Okay, suppose in this case XY is equal to PR, YZ is equal to QR, and X is equal to PQ. So the three sides of this triangle are equal to the three sides of this triangle respectively or in corresponding way. So we can say that these two triangles are congruent to each other. Now here we see two triangles PQR and XYZ. The length of PQ is 4 centimeter and here we can see the length of XZ is also 4 centimeter. Okay, so PQ is equal to XZ. Fine. Similarly, the length of QR is 5 centimeter and the length of YZ is also 5 centimeter. So line segment QR is equal to line segment YZ. Similarly, the length of PR is 6 centimeter and the length of XY is also 6 centimeter. So line segment PR is equal to line segment XY. So these three line segments of triangle PQR are equal to these three line segments of triangle XYZ respectively. So we can say that these two triangles are congruent to each other. Okay, and this type of congruency we call SSS, that is side congruency. Okay. Now let's discuss SAS congruence. In this case, two sides and the included angle of the triangle are equal. Okay, here we can see this is triangle XYZ and this is triangle PQR. Here the length of the line segment XZ is equal to the length of line segment PQ. I just write it over here. It's XZ is equal to PQ. Then the length of YZ is equal to length of PR. Now the included angle between these two sides, that is XZ and YZ, is 60 degree. And in this case also the included angle of these two sides, that is PQ and PR, is also 60 degree. So I just can write angle XZY is equal to angle QPR. So these three conditions, if they are fulfilled, these two triangles can be called as congruent. Okay, we have to be very clear that the two sides and the included angle, not the third angle but the included angle between these two sides. Here we can see XZ and YZ, and this is the angle which is formed between these two lines. Okay, here we can see it's PQ and PR, and this angle is included between these two. Okay, so if two sides and the included angle of both the triangles are equal, we can call them congruent. Okay, symbolically we can write it as triangle XZY is congruent to triangle QPR. This is the sign of congruence. Okay. Now let's discuss ASA congruence. That means two angles and the included side are equal. Okay, as per the ASA condition, two triangles are congruent if two angles and the included side of one triangle are respectively equal to the two angles and the included side of the other triangle. In this case, we can see length of line segment AC is equal to the length of line segment QR, and angle RQP is equal to angle BCA, and angle QRP is equal to angle BAC. That means these two angles are equal to these two angles, and this line segment is equal to this line segment. So the two angles and the included side, these two are angles and this is the included side. Okay, so in this case it is 45, 60, the angles and the line segment, length of line segment is 7 centimeter, and the same is in this case. So we can call these two triangles as congruent. Okay, I just write over here angle BAC is equal to angle PRQ, angle BCA equal to angle RQP, and length of line segment AC is equal to length of line segment QR. That means these two triangles are congruent to each other. Okay. Friends, we have to be very careful about the two angles and the included side. Generally, the students make mistake. They take any two angles and any third side as equal and they prove ASA congruence. That is actually not correct. ASA congruency is established when the two angles and the included side of one triangle is equal to the two angles and the included side of the other triangle. Okay, so be very careful about it. Now let's discuss RHS congruence, that is right angle hypotenuse side. Okay, two right angle triangles are congruent if the hypotenuse and the one side of one triangle are respectively equal to the hypotenuse and other side and one side of the other triangle. In this case, we can see this is a right angle ABC and XYZ. Just write it over here. Triangle ABC and triangle XYZ. Both of them are right angle triangle. We can see angle ABC and angle XYZ. Both of them are of 90 degree. Okay. Now here we can see the length of line segment AB is equal to the length of line segment XY, and the length of line segment AC is equal to the length of line segment XZ, and both of them are hypotenuse of respective triangles. Just write it over here. So these two triangles are congruent since they are having one angle as common, that is 90 degree, and this is a right angle triangle, and they are having one length and hypotenuse as equal. Okay, so this is RHS congruence. Now one question arises in the mind that why it is happening. Friends, we are knowing Pythagoras theorem. In Pythagoras theorem, the length of this, I just write it over here. It's Pythagoras theorem is AB square plus BC square is AC square. Okay, in this case it is XY square plus YZ square is equal to XZ square. That means if we know the two lengths, that is AB and AC, we can calculate the third length. Okay, so in these two triangles, the two lengths, that is AB is equal to XY and AC is equal to XZ. That means the two lengths are equal. Definitely the third length will also be equal. So if the third length is also equal, then this congruency is converted to SSS congruency. Okay, so these two triangles are congruent to each other. Okay, so I hope you are clear. Friends, we have discussed various type of congruency. We have discussed the congruency of geometric shapes, and we have also discussed the congruency of triangles. We have discussed SAS congruency, SSS congruency, ASA and RHS congruency. In the next session, we'll be discussing the problems based on all these topics. Okay, so do revise this session before coming to the next session. Bye-bye.